Alright, good afternoon everyone. Welcome to today's Set 4 E-Math lesson with me, Teacher Jason, over here on a wonderful 2 p.m. afternoon. Alright, so just some ground rules before we go to that. Okay, just some promotion. If you actually invite your friends to Genie Book, or you have some friends that you say, hey, let's study in Genie Book together, it's actually quite an interesting place to study with. Invite your friends along. Both of you will actually earn up to 5,000 bubble each. Okay, if you actually refer your friends. Referring to your friends, scan the QR code and you will have 5,000 bubbles each with respect to the referral. Alright, so just refer them and 5,000 bubbles each. Okay, some ground rules along the way. Just be patient, understanding as I explain the concepts along, because ultimately we are learning in the same environment. So we all learn together, grow together with this journey with me, together. Right? Next up, also along the way, this is a digital space, but ultimately we want to observe gracious and respectful behavior. Lastly, along the lesson, follow the scope for today's lesson, ask good and relevant questions. So what will be today's lesson? In this case, sets 2. Today we are going to expand a little bit. So last week you learned a bit on terminologies, what are sets, what are subsets. So today we are going to go a little bit further, learn a little bit more on the notion of proper subsets and subsets. What are the difference? Intersection of two sets, and lastly union. So what are the difference between them? So before we go to that, let's have some definitions over here that we can refer to. So some set symbols that we refer to. So when we say P is an element of set S, okay, there's this special letter that we need to refer to, which is this E with a curly sign. So we write it in this manner, E with a curly sign like this. Okay, so let me put it here. So it looks like this. So ignore the rest of finger, E with a curly sign. But if we say, in this case, if it's not an element, example for the second one, Q is not an element of S. What we do over here is this notion of writing it this way. We write the E and we say, no, we do a backslash in this manner, backslash. So exactly how my finger does, backslash down. Lastly, if I want to describe the number of elements, all right, how would I write it? Quick, type your responses. What would I say as the number of elements in set S? What will be the notation I will need to consider? Okay, think about it. Once you are clear, write it down. What is the notation? How would I write as the number of elements in set S? Okay, just write your responses. Okay, what would I write it as the number of elements in set S? I'll give you a while. Okay, to get your brain started over here. How would we say is the number of elements in set S? Okay, it seems like you guys are tuning in. Okay, just give it a while for everyone to think of what would be the number of elements in set S. Okay, let me see. Alright, very good, Sihan. Anybody else wants to try? Okay, just take note, Sihan, the brackets you're using is not that particular bracket. That bracket will be used when we are listing our elements. But, yep, the notation, the alphabets are all correct. But for the rest, how would I write it down? Let me just give it a little more time before I write down the expression. Okay, seems like everyone seems to know, but don't really want to know because you're scared. But don't worry, if you know your stuff, you can just type it out. Don't worry about it. So when we write about the number of elements in set S, is actually the notion of n, and then the brackets will be the normal curve brackets we do before we write the capital S. That is how we write the number of elements in set S. Alright, next up, our next recap. When we talk about equal sets, alright, when we say two sets are exactly equal, even though the order of the elements are different, but if they contain the exact same elements, we call them equal sets. And in this case, we say that the number of elements in both of the sets are equal. So example, one very simple example I can give you all. P is my set, in this case, say 1, 2, 5. That is where I use the curly bracket. So Sihan, you can take note over here. And Q, even if I write it in a different order, say 5, 2, 1. Both of these sets are exactly the same because they have 3 elements and also all of them are the same as well. Like the elements itself are the same and they have the same number. Okay, so that is the notion of equal sets. Okay, I hope this is clear. Now, more recap over here, we can talk about equal sets and as well as empty sets. So an empty set in terms over here, we say that it does not contain any elements. That means it does not contain anything at all. So how would we write it? So in this case, you can say in this manner, please take note, careless mistake over here usually people do not write a 0 inside because 0 is still something, it's a number. So we either write this or we write a O with a backslash. It means nothing, empty set. So therefore, P is also called an empty set, or we can also call it another name. Now, let me bring this down to the floor. Does anybody recall the other name that we can call an empty set? What is another word? What is another word we can say? Come, give it a try. Write down your responses. I actually want to see whether you all recall, because these terms can come out in terms of your examination as well. So what is another word we can write down besides calling it an empty set? Okay, think about it. Look through your textbook, or if you can remember, what is another word I can call an empty set? Anybody wants to try? Very good, Ivan. That's actually a correct word. Anybody else wants to try? Bring it down to the floor. Don't be shy. What is a particular word that we can write down? Okay, I'll give it a few more seconds for those who are still thinking, what is that particular word I'm looking for? Is it going to be, I don't know, duck hole set? I don't know, some other name. What is a particular name that I can write down? Okay, so it seems like everybody is really getting it, but just a little bit shy to write down. Okay, don't worry. So the name here we actually call is a null set. So empty or a null set. Okay, so this is what we call an empty set. And lastly, also what we can actually sort of recap is this thing called our universal or complement of a set. Now, in this case, universal set, as the word universal, you can link it to the word universe. It means it contains everything. So therefore, this particular alphabet here is what we call the universal set. So just a recap on how we actually write the alphabet. We call this alphabet here C. C is what we call the universal set. And in this case, the set of elements in C, but not in A, is what we call the complement. That means the outside of set A. Okay, denoted, what we denote by, in this case, A prime. Now let me just bring it out to the floor to see whether you all still recall A prime. Give me an element that is A prime. Give me an element that's A prime. Just one number that's A prime. Come, give me your responses. What is an element that's A prime over here? Just type a number based on this particular set over here. What is a number that's A prime? Come, write down your responses. What is a number that is A prime? Alright, very good, Sihan. That is an element. Anybody else wants to try? Just write down a number. What is a number that's A prime over here? Okay, A prime means the number that is outside. Anybody else wants to try? Give it a shot. Think about it. What is the element that's outside? Just type a number, write it down. What would be an element that's outside? Give it a try. Alright, Fion actually give me almost all the numbers. Alright, you're almost there, Fion. There's actually 2 more numbers. Very good, Ivan. That's actually correct. Very good, Fion. That's actually the perfect notion over here. Anybody else wants to try? I'll give you a few more seconds for those who wants to try. Okay, so you realize if I want to talk about A prime, very good, Fion, you have given me the answer, and good to those who have tried as well. But for those who are saying, I'm very unsure. If I look at A prime, it's basically, I'm looking for this circle and the ones outside the circle. So I'm looking at the ones outside here. So therefore, I'm actually looking at, how would I list A prime? Take note, how to list my elements? We write A prime. Start with this curly bracket and we separate each element with a comma. So it's going to be 1, 3, 7, 9, 11, 13, 17, 19 on a proper way. That's how we write it. Okay, now this is all the recap we need to do, because what happens, we can actually link it to this thing called the first concept of the day, proper subset. So what does it mean to have a proper subset? And how can we draw a Venn diagram to see this? So what does it mean to be a proper subset? So we consider these two sets over here. Now, before I actually show you the Venn diagram, think about this. Okay, what does a subset look like through this particular relation? So if you look at P, look at Q, can you tell me which one, let me give a hint over here, which one seems to be the smallest set that is involved? Is it set number P, or is it set number Q? Or to properly say, is it set P or set Q? Which one is the smallest set I'm looking at? All right, Fion, that's actually correct. Anybody else wants to try? Which one is my smallest set? Anybody else wants to try? Okay, seems like it's a little shy here. I'm sure. Which one is it, P or Q? So if I actually look at it, Q is actually the smallest set. So how do I draw the Venn diagram? It actually looks like this. So it's P and Q, whereby Q is inside of P. So that is the notion over here, whereby the common elements that are involved is actually my 1, 5, and 9. Okay, they are inside of Q. But whereas the elements that are not inside of Q, I will have to draw them outside, which is my 3 and 7. So these are the ones that are outside, and these are the ones that are inside. So this is the notion of the proper subset, because if we look at a proper subset, okay, every element of Q, do you all agree, is going to be in P? But to be a proper subset, that means properly a subset, to be properly contained, Q is not equals to P. That is very, very important when we talk about a proper subset. Which brings down to saying that since Q is not equals to P, but Q, whatever is in Q is in P, so every element in Q is an element of P, we call it a proper subset. So the notation to write it is Q with this little awkward C over here, long C is equals to P. So it's like this way, but it's longer. So I hope you all can see my finger. So it's this way. So it's like a C drawn here. Q, it's a proper subset of C. But now let's bring it down to the next one. I can have a proper subset, but I can also have a subset as well, right? So let's consider what is the particular difference that we have. Suppose I have a set that I've defined already, X. And I want to say, okay, Y is my proper subset and Z is my subset. Okay, so let's go to Y first. Can anybody throw me a proper subset of X? Just give any responses. I want to see what is a proper subset of X. Just give it some try. What is a proper subset of X? What can we say? Okay, which particular one is a proper subset of X? Okay, that's correct, Fion. Anybody else wants to try? What is a proper subset of X in this case? Okay, so Fion actually gave me an answer. This is one of them. So a single element of 5 is a proper subset. Okay, what else can I have? What else can I have? Let's think about this. If a single element of 5 is a proper subset, can I say a single element of 7 and 11 as well are proper subsets of S? And if you follow the picture, my proper subset may not contain only just itself. It can contain more than one element, right? So therefore, in this case, can I say it's actually 2 of them? But let me bring this down to the question for everyone. Can my proper subset contain 3 elements in this context? Yes or no? Write down your answers. Yes or no? Can my proper subset contain 3 elements? Yes or no? Okay, simple yes or no answer. Just give it a try. Yes or no. All right, Fionn gave me an answer. Anybody else wants to try? Okay, just give it a down. Can I have all 3 elements in my proper subset? Okay, Sihan says yes. Okay, let's give it a try. So I have a mix of response as well. Anybody else wants to try? Okay, so I'm accepting responses here to check whether you all know whether a proper subset can contain 3 elements in this case. It seems like it's a little unsure. Okay, so let me bring it down. My proper subset actually, yes, Sihan, that's actually correct. Actually cannot. Because my proper subset, to be a subset properly, I know I'm just rearranging the words, we cannot contain all 3 because it must totally contain inside. I don't know whether you can see. So this is a circle. It must totally contain inside here. It totally contain inside. So what we do in this case, we cannot have an extra element here. And take note, there's a special set where it's a proper subset. My empty set is also a proper subset because there's nothing. There's nothing in Y, but nothing I can still put inside a set that contains something. So an empty set is always a proper subset. Now, what about a possible subset? So I relax the condition a bit. Okay, so in this case, a subset is actually all the elements over here, but to be a subset, let's think about this. Does the whole set over here, 5, 7, and 11, becomes a subset of X? Does it become? Based on this notion over here, you realize that is the relaxed condition we have for subset. Because a subset, in summary, between the difference in the proper subset and subset, what are the difference over here is proper subset, I need to perform my job as a subset properly. So I actually need to be contained. But subset, okay, as long as you're contained inside, regardless whether it's just a little bit or the whole thing, I will fulfill myself as a subset. So therefore, what is the difference between these two? If all elements of Y are also elements of X, okay, in the relaxed condition, all elements of Z are also going to be elements of X. So in this case, they are okay. And take note, for subset, this is very, very important. Both of the sets may be equal to each other because it's not really properly a subset. I'm not sitting in properly. I'm containing it, but okay, since I contain you totally, I still consider you a subset because you can contain in me. But to properly contain, Y cannot be equals to X. And in notation, this is a little bit weird over here. Y is a proper subset. We write it this way. And since we say a subset is this way, and take note, we add a little sign over here. Okay, why a little sign over here? This is like my equal sign because of the notion that they may be equal. All right, I hope you guys are getting this. So for a proper subset, how do we write it down? Set Y this way and set X. Okay, so this is to properly contain. That is the notion here. But for a subset, I can have two choices since it may be equal. So it can be, okay, if you are smaller than me, I still let you be here. But if you are equal, which is the notion of, let's say this is my set X, and somehow my subset is going to be over here. Okay. Set Z, sorry for that, not X. I still call you a subset. It's like, okay, you are a subset. You totally contain me. You have all the elements, but okay, you are not really properly a subset. So I give you a chance. I still call you a subset. But to be called a proper subset, there must be sort of some space over there. Right? So two ways to visualize for a subset. It can be totally the same, so like an equal set, or to be a subset, you can say, oh, okay, I can properly contain. But to be a proper subset, it must be properly contained like this. All right, so I hope this is a proper notion to how you guys understand what is a proper subset already, because how does a question come by like that? This is a particular example. So suppose I have two particular sets given to me. In this case, let's highlight the important things. Multiple of 4 between here and multiple of 12 between here. So list all my elements in E and F in set notation. So it's basically from your previous lesson, set E. Now give me an element in E over here. Come, just write down answers. Any element in E. What is an element in E over there? Come, write down responses. What will be a proper element in E? Give your answers. Just write down answers. Okay, okay, very nice. I see an answer. Okay, I know 4 is an answer. It's a multiple of 4. Perfect, Fion. That's actually the perfect set I'm looking for. So 4, 8, 12, 16, 20, 24, and 28. Okay, and now if I look at F, it's a multiple of 12. I'll follow up from there. It's just going to be 12 and 24. So if you realize over here, based on these two sets, you realize, aha, F is going to be contained in E because I have these two common things. So therefore, if you were to draw my Venn diagram, so it's going to be like this. Okay, so it's going to be this way, where E is going to be my bigger set over here. So let me just fill my numbers. F is going to be my smaller set containing 12 and 24. Okay, whereas the rest is going to be 4, 8, 12 is inside already, 16, 20, 24 is inside, followed by 28. That is the notion over there. So it's going to be 12 and 24, and then the rest of them in E are outside. Now, for this question, is F a proper subset of E? Write down answers. Is F a proper subset of E? Yes or no? Is it going to be so? Yes or no? Will it be a proper subset? Come, write down answers. Is it going to be a proper subset? I have the two things over here already. They are not equal. So are they a proper subset? Very good, Fion. Anybody else wants to try? I bring it down to the floor. Very good, Ivan. Anybody else wants to try? All right, so if you realize over here, good job, Yvonne. Good job, Fion. Sorry for that. Good job, Ivan. Perfect. They are actually a proper subset. But the reasons to state them, two things. Firstly, if you want to explain your answer, we must say that the elements that are in the smaller set, which in this case F, are also my elements in the bigger set, which is E. And there is one particular thing that you must take note, proper subset, which is very, very important, that F, is it equal to E? Yes or no? Will F be equals to E in this case if I want to be a proper set, proper subset? Yes or no? Okay, I'll give you all some time. Okay, so if you realize, to be a proper subset, F must not be equals to E, and henceforth, this is important, very important when you list your proper subsets. This is very, very important if we were to state our proper subset. Very, very important over here. So when we talk about proper subset, not only my elements of F must also be elements of E, this must come out as well. So very, very important pointer to take note. All right. So now with this notion, let's see how you guys will fare off for the first bubble question for today. All right, so I'm going to launch the bubbles, launching the bubble in 3, 2, 1, let's go. This should be all right. Okay, let's see how you guys will fare in this question. You have 1 minute and 30 seconds. And in this case, I will encourage you all to list down the elements so it will be helpful for you all. All right, perfect. I see good responses over here. Very good, very good. So I will encourage you all to list down the elements, okay, before you answer this, because if you guys don't list down, it's going to be a little bit hard. Okay, very nice. Okay, you have 50 seconds more for those who have to clock in your answers. Please clock in as such. Last 40 seconds. So, as said, encourage you all to list down the elements in P and in Q and let me know what is the correct answer over here. Okay, I have 30 seconds left. For those of you to write your answers down, please write it down as such. Yes. So last 10 seconds roughly. Last 10, sorry. I'm not rushing you all, so don't worry about it. Okay, last 5, 4, 3, 2, 1. Okay, very nice. So most of you actually managed to get the answer. But for those who have not, don't worry about it. I'm going to go through. So x is a prime number less than 10. So our prime numbers are actually 2 is my prime number. So that's why some of you answered 4. So take note. 3, 5, 7. These are my prime numbers less than 10. And q, it's going to be an odd number. So odd number, take note. There is a strict inequality here. So I cannot include this number. So for those of you who write 1 and think about, oh, my answer should be 1. So take note over there. It's not. It's going to be 3, 5, and 7. So from here, you have to take note. Q is contained in P already. So therefore, but they are not equal. As we can see, they are not equal to each other. So therefore, we follow the notion of Q is a subset of P. So this is what we know as a proper subset. Yeah, I hope you guys got this. All right, okay. So good job to everyone. For those who have not, I hope you all have learned something important over here. Okay, now bringing on to the next concept, which is my intersection of two sets over here. So what does it mean to have an intersection of two sets? Okay, so suppose my Venn diagram like this. Okay, suppose my Venn diagram. Okay, suppose I were to define my Venn diagram like this. So 1, 2, 4, 8. So just listing down any elements over here. 10, 6, 7, 9, 3, 5. Suppose my sets are defined in such a manner. Okay, now what happens is this. When I talk about the intersection, okay, which one will it be? Okay, let me just define for you. When we talk about the intersection, is it gonna be, okay, let me just highlight the region for you. Is it gonna be this green color region here, or the red color region, or the blue? Or the one outside. So green, red, blue, outside. Write down a response. So when I talk about intersection, which one is the one I'm looking for? Green, red, blue, outside. Outside means outside the region. Okay, Ivan gave me an answer. Who else wants to try? Okay, in fact, just to give you a heads up, it's correct. Your answer is correct. But who wants to give it a try? Green, red, blue, outside. Where is my intersection? Okay, seems like it's a little bit unsure, so don't worry, let me get through. Now, when we talk about the thing intersection over here, we are talking about what is common between A and B, because two sets, which is the common one, which part does the set A and B intersect? So if I actually continue on, A intersect, okay, so this is set A, so this is set B. Where do they intersect at? At the green color region in this case. And when we classify A intersect B, it is actually the region in between over here. So that is how we say A intersect B. In this case, this is a set as well, just that we call them 2, 4, 8. This is the way we classify the set. But there's also another way. We have this as a set. We have also have the complement of this set. That means the opposite of this set, which if you look at the animation, that means I'm looking at the opposite, which is basically all my elements in pink. In this case, 1, 3, 5, 6, 7, 9, 10. So we can have the complement, or we can also have just the intersection itself, which is 2, 4, 8. So the common elements whereby they have between two sets. Okay, so this is what we know as the intersection, which we classify in such a manner. All right, I hope everybody got this down. But there is also, I hope everybody got this down first before I carry on. All right, perfect. Okay, but now there is also another case whereby there's also another case first. Let me not spoil the party. There's also another case. Now look at these two particular sets. How will they look like in the Venn diagram? So look at them closely. What is one thing you notice about these two sets over here? In this case, let me bring it down even more specific. Is there anything in common between these two sets? Is there anything in particular, anything in common? Yes or no? Write down your responses. Yes or no? Okay, I'll give it a try. Let you think about it. Is there anything common between these two sets over here? Then you are confused. Okay, is this a trick question? No, just think of it straightforward. Is there anything common? Okay, Fionn gave me an answer that's actually correct. Ivan gave me an answer as well that is correct as well. There is nothing in common. So since there are no common elements, there shouldn't be an intersection, right? So there should be nothing there, right? So how should we draw it? So no common elements. So how do we draw it? How will we write it? In this case, in terms of a Venn diagram, we say it's this way. So essentially, they're just two separate things. So therefore, if I want to write it out, so how would I say it? And how would I define it? So in this case, the set C and D, what happens? They do not share any common elements. The special name for them is we say C and D are actually disjointed sets. And in this case, since they are disjointed, there is no intersection. The intersection is empty. So that is how we classify if there is no intersection between these two sets over here. All right. Now, with regards to intersection, how do we actually write out such a question? In this context over here, similar thing, but let's see the contents of the set. That's very important if you actually want to write down our sets. So first, G, positive integer, factor of 16. H is an even number between 0 to 10. Now take note over here, this is a little tricky. I hope you'll realize that G is a positive integer and a factor of 16. So my factors are 1, 2, 4, 8, 16. H is an even number. In this case, I take note of 0 because there's an equality here, but I stop at 8. Why didn't I include 10? Because it's a strict inequality here. So that's why I did not include 10. And if I want to find the intersection. Now, so if I want to find the intersection, what will be one of the element that will be inside? Come, show me a response. What will be one of the element that is inside the set G intersect H? Let me just write down the Venn diagram. What will be a particular element that is in G intersect H? Write your answers down. Okay, write your answers down while I draw. Write your answers down. What will be an element in G intersect H? I'll give you all some time. Let's think about it. What will be an element in G intersect H? Very good, Ivan. You gave me the whole set. Perfect. Anybody else wants to try? Anybody else wants to give it a shot? Very good, Fionn. Anybody else wants to try? Anybody else wants to take a challenge? Okay, so before actually drawing the Venn diagram, we can realize intersection means the common elements. So common, I hope you all realize, is 2, 4, and 8. Common things over there. So that's why intersection, what are the common things? Which part do they intersect at? So they should have something in common. So therefore, this should be my elements, in this case, 2, 4, 8. So therefore, when I draw my Venn diagram easily, that's why I draw a Venn diagram. I know inside is 2, 4, 8. Rest of the leftovers, G should be here with my 16 as well. H should be the other side, 0 and 6 as well. Now, hence, if I want to find the complement of this, can anybody then tell me what will be an element In this set, give me an answer. What would be an element in this particular set that I have? Just list down answer, or if you want to list all, I'll give you some time before I go on. Give yourself a little while. What is one particular element, or if you want to, list down all the elements that are in this particular set. Give it a try. What will be a particular element in this set? So this one a bit confusing, right? So let me give you a hint. This is my intersection. I want something that's outside of this set. So what is outside? Give you a hint. Anything outside, first one will be 0. Very good, Fion. That's one answer. Very good, Ivan. Perfect, perfect. So it's going to be 0, 1, 6, and 16. Because the other ones outside the green color region, they have just wrote. So Fion, you're actually correct, but just that you missed out 2 elements. But it's okay. That means you understand, Raf. That means you understand already. Just 245. We actually have to include every element here, which is perfect over there, Ivan. Good job. Now, I hope you guys know what's coming up next. Bubble question number 2. So, between these two, you can actually find out what is my intersection, list out the elements, and draw the Venn diagram. It may help you a lot because with the Venn diagram, you actually can see instead of listing them out. Okay, counting down in 3, 2, 1, let's go. All right, so be very careful. I'm looking for the intersection. This means the intersection. Okay, so be very careful when you list. Okay, what is the intersection? So one good way is, take note, always list down your elements first. Don't rush it down before you tell me what is the intersection of the 2 sets. And read the description of the set very, very carefully. All right, very, very important. All right, very good. All right, perfect, perfect. 50 more seconds for those of you to answer. Write down answers as such. I'm looking at the responses. So if you realize why I'm not looking straight into the camera, I'm looking at actually your responses, and it's quite pleasing, I would say. Counting down to my last 30. Let me drink some water first while you guys attempt. So read the set carefully, and this word, very important, this particular word over here, inclusive. What does it mean to be included inside? Counting down to my last 10. Give it a try for the, I think I still have 2 of you who have yet to answer. Okay, 1 more actually. Counting down to my last 5. Okay, time's up. Okay, so I actually have a mixture between 2 responses, and let's see. So I hope you all realize that x is an integer between -4 and 4. So -4, -3, -2, 1. 0 is an integer as well, but doesn't matter. 1, 2, 3, and 4. Now, Q is a little bit tricky because I'm looking at a single digit prime number. So what is a prime number? In this case, if you were to realize, my prime number is going to be, it has to be positive, first one. It's going to be 2, 3, 5, 7. Take note, this is my prime numbers. Okay? I hope you realize some of you all where you went wrong. Because 1 is not a prime number. Take note, 1 is not a prime number. So if I look at this, for some of you who answered 2, you guys got tricked because there's only 2 and 3. There's no 1. So that's why my intersection is 2 and 3. Okay, 1 is not a prime number because a prime number is defined by a number that has 2 factors, 1 at itself. But 1 has only 1 factor, which is 1. So that's why it is not a prime number. So take note, my answer in this case is actually number 1. So good job who have got it. For those who have not, I hope we have learned something over here and we continue to grow as we continue with today's lesson. All right, perfect job over here. Perfect, perfect. Good job over here. Now, let's go on to the last part of today's lesson, which is the union of 2 sets. So now, we have intersection. Now we have union. So what is the difference between the word intersection and union over here? So union means, hey, You can think about it this way. Suppose, hey, let's join parties together. So let's union together. So what you all do, you all shake hands. Now you can think about the shaking hands part as like the intersection. This part where you intersect. But when you're union together, you realize there are certain parts that you all do not share. In this case, example, you all do not share the same face. You are all not connected by the same legs. But in this case, you are connected by the heads. So the notion of union is actually remembered as such. Union of two sets. Suppose looking at this animation, again, let me fill in, let me rewind first, sorry. It's not supposed to come out first. Okay, sorry, Sorry for that. Okay, let me just, intersections. Suppose, let me fill in these numbers. So, 1, 2, 4, 8, 6, 10, 3, 5, 7, 9. So, when we look at union, so this one I'll slow down because it can be a little confusing. So when we talk about union over here, using the handshake example I talked about just now, there will be something in common between these two people, which is they are joining together by the hands. So that's the intersection part. But however, they are not intersecting by the heads. They are not intersecting by their legs. So you can picture that when you do a handshake with your friends, if you were to do a handshake. Okay, so what I meant is, picture this part as the handshake. And picture this part and this part that is not connected by the handshake. So therefore, when we look at the union of two sets, it will actually be A and then B, and we are connecting them by the handshake, but certain things are not connected. This is where I have A union B. They are either A or B or both. That means when you do your handshake, either you're connected by the hand, or if you want otherwise, either you or your friend or the handshake that you two are connected with. So that is A union B. In this case, everything in orange is my union. So in this case, not only the intersect, but also the ones in A or B. That is what we call the union together. So A union B, that is the notion over there. And in this case, we can follow up with the complement, which is exactly the ones outside, which is in this case the mint color, which is in this case A union B bracket complement prime, or in this case complement of A union B. So I hope this gives a better picture of what is the notion of union, where if I were to rewind my animation over here, let me just go to that notion. All right, A union B is this over here, either A or B or both, and then the complement on the other side is just everything that's outside. Okay, so I hope this gives it a clearer picture before I actually bring down to my work example 3. So now, suppose this is my set, and in this case, sometimes in context, the universal set will be given to you. So in this case, I'm considering a single digit positive integers. So before I go down, and let's refresh a bit, in my universal set, what is a particular number in my universal set? Come, write down your response. So in my universal set, what is a particular number or an element in my universal set? Give it a try. I'll let you think about it. Single digit positive integer. The keyword is positive over here. So what is an element inside? What is an element inside? Okay, Fion almost there, but a number should not be there. Let me give you a hint. Ivan, that's actually correct. But Fion, let me give you a hint. A particular number should not be there. You're almost correct. Yes, that's right. So when we talk about positive, it's always a number greater than 0. Anybody else wants to try before I write down all the answers? All right, so for Fion, Ivan, good job for the rest. I hope you all are following. But in this case, you want to give your answers. That's also good as well. So 5, 6, 7, 8, 9. Now from here, my element in A. Let me see whether you guys still recall, given the universal set, what should be an element in A and what should be an element in B. So for A, give me an element that describes perfectly in the description here. Element in A, write your answers down. What is an element in A? Very good, Fionn, perfect answer. What do I have? Anybody else? And if you want to follow up, you can write me the elements in B as well, A and B. Okay, so we quicken the process a bit, A and B. Okay, sorry. Before I confuse you, I'm not talking about the intersection. So basically, you have listed the elements in A. If you want to, you can list the elements in B as well. Perfect representation, Ivan. So in this case, we talk about this. This is actually 2, 4, 6, 8. And what about the elements in B? What will I have, everyone? Come, give it a shot for everyone who has not written. Okay, Fionn, in this case, you are missing one element. There is a particular number that fits into the set as well for B. For the rest, you can give it a try. Don't be shy. Don't be too worried about it. All right. Yes, Ivan. Yes, Fionn. Perfect over there. Anybody else wants to try before I were to draw my Venn diagram? Let me just draw first. Give everyone else a chance. Oh my God. Sorry for that. So this way over here. Okay, seems like everyone got it, but just a little shy, so don't worry. So B is actually 1, 2, 4, 8. So from here, I can actually write down my sets. In this case, A is find the so usually when I draw my Venn diagram, what I'll do, I'll find the common elements first, because those will fit in to the small space over there. In this case, 2, 4, 8. Otherwise, A will have 6, B will have 1. And take note, do remember the rest of the elements that may be outside as well. So 2, 4, 8. And in this case, 2, 4, 8. Otherwise, we have 6 and then 1 as well. So we still need 3, 5, 7, and 9, which will be written outside of this particular set. So 3, 5, 7, 9. 3579, that's how we write it over here. And henceforth, what are the questions that can come out with this particular Venn diagram? So they can ask you in this case, from this Venn diagram, I want to find A union B. So in this case, can anybody tell me what is one element in A union B? What is one particular element in A union B? Come, write your answers. What is one particular element in A union B? Over here, or in this case, if you guys are confident, you can write down the whole set of A union B. I'll give you all some time over here. So I'll give you all maybe 2 minutes. Let's think about it. What is an element in A union B, or in this case, all the elements in A union B? Perfect, Fionn, but I think you have skipped a little step. You have answered this for me. I want this one. That's actually correct, Fionn. You're doing a good job, but let's consider this one. Let's think about this. I want the A union B, not a complement, but the union. Okay, I'll give you some time to write it out. Don't worry about it. For the rest, give it a shot as well. Perfect, Ivan. Anybody else wants to try? Perfect. Okay, anybody else? I'll bring it down to the floor. Anybody else wants to try? Okay, so seems like you guys have gotten it, but just a little shy in terms of expressing yourself, so don't worry. So A union B is in this case 1, 2, 4, 6, 8, whichever it is inside over here. And the elements outside will be 3, 5, 7, and 9, which is the ones that's outside in blue. Okay. So good job for the work example. I hope you guys have understand this, because we are actually going to our very interesting last bubble question for today. Very interesting. So you realize what happens? So how would I answer this? This is very interesting. In this case, instead of numbers, I give you alphabets. How will we do this? Okay, in this case, it will be very, very important on how to write the sets. Launching the bubble in 3, 2, 1. Let's go. So it would be very important if we were to label our sets M and N. Okay. All right, perfect. Okay, I see some answers as well. Okay, take note. Awesome. All right, good job. Keep your responses coming in. Keep your responses coming in. So I hope you guys remember what's a vowel. Okay. And what's I hope you guys remember what's a vowel. Okay. A little more than 50 seconds. Counting down to my last 30 seconds. Counting down to my last 25, I would say. Okay, for those of you to do. So what happens, we can list out the elements first, or in this case, the Venn diagram will be very, very useful over here. Counting down to my last 10 seconds. For those of you to answer, you have 10 seconds to do so. Counting down to my last 5, 4, 3, 2, 1. Okay, so this one is a little bit hard, but I see that most of you all got it. Very good. So let's list down my elements first. So I hope you all realize over here, a vowel is basically these alphabets over here, A, E, I, O, U. But in this case, X is a letter in the word banana. So when we say a letter, we only want the letters that are involved. We don't want the repeats. So A, B, and N. So these 3 letters. So take note, do not repeat them when they say letters. Unless, usually in terms of the word, when they say the word letter, N is a letter. Don't need to write N1, N2. They never state that. So when we write a letter, we do not repeat them. Take note. And so if I want the union, it's either in A or B or both. So in this case, I'll write there's A in both. There's only A in N, but I'll write it down. There's in this case only in M, but I'll write it down. In this case, I in M, but I'll write it down. N O U. In this case, this is my set over here. A, B, E, I, N, O, U. So therefore, this is the notion over here. So for those who have answered 1 or 2, 1 is only, in this case, my vowel. 2, in this case, is you realize this is the intersection I'm considering. So take note of the errors over here. This is my union. Intersection is this one. All right. Okay. So I hope you got this down and there are no confusion over here. So therefore, what happens is this. We have this notion. We have covered union, we have covered intersection, but now let's combine all 3 within a try it yourself. So in this case, this try it yourself, give it a shot. It actually combines all 3 particular concepts. Given the information, how do we find the union, intersection, or how do we know whether it's a proper subset? So try it yourself, okay? Give your answers in Genie Ask, so the things will be given informative. I believe you guys are clear. Or if you guys are not clear, you can just ask in the Genie Ask platform on how you can submit your answers to get, in this case, 50 bubbles. Not too bad, 50 bubbles over here to not only test yourself, but you get rewarded for your efforts as well. So give it a shot, try this question out. It actually tests out whether you know the content for today, which is the notion of, okay, before I go through that, now why are we learning sets in this case? There's a little fun fact over here. Why are we learning sets? So in this case, Venn diagrams are actually popularized, or in this case, it's popularized by this mathematician. As you can see, the word John Venn. So that's why the word Venn diagram. Okay, so that's why you realize if certain notations or certain formulas are introduced by a mathematician, usually it's by their name. So John Venn, that's why Venn diagram. But however, this particular notion over here, Venn diagrams, is already introduced as early as the 17th. It's 1712. So the year. So that's where we were born. So interesting to how something so old can be actually present into now. And what have we gone through for today? We have known what is a proper subset, what is a subset, intersection, and my union. So, and how we see these questions can be combined in a particular single question. So that's it for today. Actually, that's it for today. If there's any questions and answers that you would like to do for me, please feel free to share. Otherwise, I hope you guys understand my content for today. Good job, everyone. Thank you for staying with me. And from there, this is Teacher Jason signing off, and I will see you all next week. Take care. Bye bye.